Wednesday afternoon at the symposium in Long Beach, California. This is Steve Koster of Espresso Engineering. Got a chance to catch up with Bruce Archambeault of Applied EM Technologies. How are you doing this afternoon, Bruce?
Doing well. I'm doing very well, thank you.
Very good, very good. Now, Applied has all of these products. Can you tell us a little bit about them?
Sure. So we have a series of devices to try to help people that run labs make sure that they can check out their equipment and make sure everything's working properly and so forth. One of our most popular products is this sphere here, and this is actually a spherical dipole. And so there's electronics inside it that are a comb generator with 4 different comb fundamental frequencies. And it ranges anywhere, as a standard product, ranges anywhere from 10 megahertz up to well above 10 gigahertz, okay? And so we can create an electric field that's either horizontally polarized like this, or we can turn it so it's vertically polarized. And as you can see, there's no cables leading up to it that would affect the fields or anything. It's battery operated. The batteries give us 4 hours or more, depending on how many battery sets we put into it. And it's very easy to use. Some of our customers use this to compare, for example, a G10 cell to an open area test site, or a 3-meter test site to a 10-meter test site, so that they have some idea about the relationship back and forth. You know, one of the unique features about this is that there's a pulsing function where the comb is actually pulsed on and off. And as you know, the commercial EMC requirements require us to use a quasi-peak detector. Well, how do you know your quasi-peak detector is working unless you have something that's pulsing on and off? And so this has the ability, with a simple push of a button, to go from constantly on to quasi-peak, so you can do your quasi-peak measurement, see that it's different than the peak measurement, and have a good feeling that your equipment's really working. And you know, it's very expensive to find out after a week's worth of testing that the cable was broken or something wasn't working properly, right? You got to go back and do all that again. So people are not very happy when that happens. We also have this version here. This is called the DRFS, where the sphere is called a USDS. USDS stands for Universal Spherical Dipole Source. This is a direct RF source. And so now it's the same circuitry, really, same battery operated and everything else, same comb frequencies. But now if you wanted to use a different antenna for some reason, you really like to use your horn antenna to cause the fields to be radiated, then you can hook it up to this with just a simple SMA connector. The other source we have here is called the USB source, and we call it a USB source. This is also a comb generator. Now this is only 1 clock frequency where the other 2 have 4, but the big thing is, instead of using batteries, it has a USB connector where it gets power. So the intention of this is, if you want to check your receiver or your spectrum analyzer, nowadays most of these things have USB ports on them, so why have batteries and a power cord that goes into the wall and all that? Just take a little USB thing, plug it in here, take the SMA, plug it into your receiver or your spectrum analyzer, you see the nice spectrum, make sure everything's like it was the day before, the month before, whatever. This is very inexpensive, obviously fits into your shirt pocket, and a very, very popular type thing. It's not your shirt pocket, my shirt pocket. And then finally, we have our precision spherical dipole source. These have been around for a little while, and gold plating on it, you know. And this is more expensive, but what this does, we have fiber optic cables that are going in and out, and so we have a base unit, a control unit that you would plug signal generator into. That signal generators, the sine wave from the signal generator is converted into optics, comes up through here into here, the same kind of spherical source here, spherical dipole source. And so the signal is come up and applied to the antenna, the spherical antenna, and then the thing that's unique about this is that there's a detector right where the signal is fed to the actual antenna portion of this, and that comes back down through this other fiber cable. So you can adjust the amount of input power to this to make sure it's the exact same amount as what you had last week, last month, or whatever. And if you end up with for example, you want to do shielding effectiveness measurements, well, you know, as soon as you put any kind of a source antenna into a shielded box, the shielded box loads that source antenna, right? So you have no idea how much power is actually being radiated from your antenna once you put it in the box, and how close is that to what it was when it was outside the box. So with this, we can adjust that amount of power so you get right back to the same level and get a very, very accurate shielding effectiveness measurement without having to worry about that loading effect. And so these have been very popular. In fact, we've got a number of customers that have this, but as I mentioned, this precision sphere is a little bit more expensive than the comb generator, but on the bottom line is these comb generators are very, very low cost, so that you can have this in your lab. I've even had people compare one company's lab to another company's lab, or in cases like your company, for example, where you have multiple chambers, you could do repeatability testing within yourself just to make sure everything's the same, and no matter which lab you measure in, you're going to get the same answer.
Yeah, right. And I was looking at that because we, at the lab, of course, we do a validation of the site every morning. We've got a little generator that we turn on. That would be perfect for that application.
It is, and as I mentioned, we can do this either horizontally polarized like this and or vertically polarized, and the benefit for a sphere like this over a normal monopole type antenna, like most of these kind of comb generators are, that if you take a monopole antenna like this, but turn it sideways, well, that's not a monopole antenna anymore. It's some kind of weird radiating structure that the mathematics can't even begin to talk about, And if you're extremely careful to put it the same way every single day, then you could get repeatable results. But any little change in motion on this, position on this, is going to make the results change very, very quickly. This doesn't matter. There's no cables, there's nothing coming up to it. Whether you have it this way or that way on this yoke platform, it'll give you the same answer every day. And very repeatable. And as I said, this is a dipole, so you get the standard dipole pattern that is uniform through one plane. And of course, you get the donut kind of pattern for the dipole.